right, let's jump right into lesson 45, boys and girls. Today we will be writing decimal numbers in expanded notation, and we're also just going to take a quick peek at other ways to write multiplication equations so that you're familiar with all of the different ways mathematicians like to use. First, we'll begin with expanded notation. Just like we can use expanded notation to write whole numbers, we can use expanded notation to write decimal numbers as well. Let's take a quick peek at our chart and just review a few things. Immediately to the left of the decimal point is our ones place value, and going to the right we have tenths, hundredths, and thousandths. It's written out in words right here and in number form right up here. So if we're given a number like 4 and 25 thousandths, we would use expanded notation in this way. We would write in parentheses 4 times 1. In other words, our number in that place value times the value of that place value. 4 times 1. Since we have no tenths, we do not need to write it in our expanded notation form. We simply omit it. However, we are careful that when we indicate we have 2, we use it in connection with its proper place value spot. The 2 is in the hundredth spot, therefore we have 2 times 1/100th, again our digit times the value of that spot, plus 5 times 1/1000th. Our book reminds us that zeros that serve as placeholders are usually not indicated in expanded notation. In example 1, we're asked to write 5.06 in expanded notation. Let's try to do it before we turn and look at the next page. In this case, we have 5 times 1, because the 5 is in the ones spot, plus no tenths, but we have a 6 in the hundredth spot, so that would be 6 groups of 1/100th. And let's do a quick check. Hopefully we did the problem correctly. Oh, we certainly did. Here's where we solved, and here's the answer in the book. Yay! Example 2 says to write 4 times 1/10th plus 5 times 1/1000th as a decimal number. So we're simply going to work backwards. Well, better put our decimal in. Better put a 4 in the tenths spot. I notice here we don't have any 100ths. It will be important to use 0 as a placeholder to indicate that we have 0 100ths. And we have 5 1,000ths. And in this case, we've put 5 in its proper spot, and in order to be mannerly, let's put a 0 in the front. And again, our answer is correct. Now let's take a quick peek at a few other forms of multiplication you will often see, whether in this class or in your future math classes. Let's remember when we first were learning multiplication, we used the X symbol to indicate multiplication or groups of. We later learned we could also simply use a dot, and we have also learned that mathematicians sometimes don't put anything. Whenever we have 2 letters side by side, we need to just know we are multiplying those 2 letters. Now let's look at some examples down below. In this case, we've got 3 letters lined up. They are all multiplied, length times width times height. In this case, we've combined a number with a letter. It's similar to pattern 3. There's no multiplication symbol or dot, but anytime we have a number up beside a letter, we again need to know it is multiplication. And then, in this case, we have 2 digits side by side. Now, in order to let the reader know that we are multiplying 3 times 5, we put our second digit or second number in parentheses so that we don't get confused with possibly just writing the number 35. With 5 in parentheses, we know we are saying 3 times 5. One other point to remember is that down below, look at this, we have 3 times 5, 3 times 5, 3 times 5. Each of these forms is absolutely fine and correct to use. I probably wouldn't use the 2 parentheses form quite as often because it's not as simple, quick, or easy. Our book wants us to remember that we can flip-flop our order of factors and still have the same product. 3 times 5 is 15, and 5 times 3 is 15. Do you remember what the property is called, boys and girls? Hopefully you're saying the commutative property of multiplication right about now. Now let's look at a problem where we have quite a few factors lined up. Oh, before we do, I'm going to highlight that property, the commutative property of multiplication. In this example here, what our book is pointing out to us is that we can take the exact same factors and rearrange them in a different order, and our product will still be the same. Let's very quickly look at this left side. We say 2 times 3 times 2 times 5 times 3 times 5. Well, that's certainly a problem we could solve, but mathematicians always do like to be a little bit orderly. And so here they've written the same problem in a little bit more polite form. They have listed all of the factors, still the same as what's on the other side, but they've put them in numerical order. Now we have 2 times 2 times 3 times 5 times 5 times 3 times 3 times 5 times 5. And again, I think our brain can a little bit more quickly look through this problem and then work to find the product. In the case of example 3, we are told if L equals 8 and W equals 5, what is LW? Well, L is 8, W is 5, and so 8 times 5 is 40, and in this case our product is 40. In example 4, we're asked to use the commutative property of multiplication to arrange the factors in order from least to greatest. We're simply going to clean the problem up. We're also preparing ourselves for exponents, which will come in just a few lessons. In this case, I can quickly scan and see that our smallest factor is 2, and we happen to have 1, 2, 3, 4 of them. So I'm going to write them out now. Our next smallest factor is 3, and we've got 2 of them, and then a 5, and then a 7. And you can see we did exactly the same down here. Please read each direction carefully before you go on with your lesson practice. And I would like you to do A, C, D, F, and H. I'll give you a minute to make sure your paper is marked. In our lesson today, we go on to the next page with our lesson practice. So, taking a quick peek at page 224, would you also do problem J? In this case, we are not only rearranging the factors in a multiplication problem, it is written in fraction form. So we will rearrange the factors in the numerator and the factors in the denominator. Remember, all of your factors in your numerator still need to be the same factors used, and all of the same denominator factors still need to appear in the denominator. In other words, our book cautions us we cannot flip factors back and forth between a numerator and denominator because we would then be changing the number.